Today we're going to look at the periodic table and the labels that go along with it. The columns and rows are labeled as groups and periods. Groups are the columns, the up and down. They're also known as families because they have similar chemical and physical properties and react similarly, just as family members would have similar traits. The periods are the rows going from left to right across the periodic table. They represent the number of shells of electrons. Each of the groups or families has their own individual name. Group 1 are known as the alkali metals. They react with water to form an alkaline solution. Group 2 are known as the alkaline earth metals. They're very reactive, but not as reactive as Group 1. The middle section of the periodic table are known as the transition metals. These metals have valence electrons that are present in more than one shell. Remember how after you fill the 4s, you go down to the 3d. So there would be valence electrons in both the 4s and the 3d, or the fourth shell and the third shell. On the other side of the periodic table, group 6 are known as the chalcogens. They are found in copper ore, and they will form water-insoluble compounds with metals of ores. Group 7 are the halogens and are very reactive. Only one electron is needed to fill the outside shell. The last column we've talked about before is Group 8, the noble gases. Almost non-reactive because they have a completely filled outer shell. There's only a couple exceptions where they react. At the very bottom of the periodic table, we have two special series called the rare earth metals or the inner transition metals. The lanthanide series are reactive soft metals. They have high melting points and boiling points and are very reactive. This is your 4F row. The actinide series are radioactive and release energy upon radioactive decay. For example, uranium and plutonium. They're also very reactive. This would be your 5F period. We've talked about metals and nonmetals, but here are some descriptions. Metals are usually solids at room temperature. Their properties include electrical conductivity. They have luster, which means that they are shiny, and they're malleable, which means that you can form them into sheets and hammer them out. They're also ductile, which means that you can draw them into wires. Nonmetals are basically the opposite. They're the elements on the upper right corner of the periodic table. Their properties include that they are generally brittle, which means that they crumble or fall apart. They're non-lustrous, not shiny. They're poor conductors of heat and electricity, and they can be any state of matter, from gases, brittle solids, and liquids. In between the two, you have some that share properties called the metalloids. They lie on the diagonal line between the metals and the nonmetals. I'm going to show you where we draw the staircase. Their chemical and physical properties are between metals and nonmetals. So let's label. Going across the groups, we had group 1, 2, 3, 4, 5, 6, 7, 8. And as you'll soon see, these numbers represent the number of valence electrons that any element in that group or family has. This first group are called the alkali metals. Group 2 are called the alkaline earth metals. The middle part here we called the transition metals. Starting from the right side, these were the noble gases. Group 7 were the halogens. And group 6 were the chalcogens. At the bottom, we had the lanthanide series. And the actinide series. These are also known as the inner transition metals. To demonstrate where the metals and nonmetals are, you need to add the staircase. It starts at group 3 and works its way down. Everything to the right side of the staircase are nonmetals. And everything to the left side of the staircase are metals. An easy way to remember this is to look on the periodic table, pick something you know is a metal, like lead or iron or copper or zinc, and see what side of the stairs it's on. They're all on the left side. Anything touching the stairs with a side is a metalloid.